All right, we are looking at target 4.7. I can use independence tests to determine if the events are independent. Okay, so last time we looked at independent or dependent, right? We knew what the situation was, and most of the time we could clearly see whether it was independent or dependent. However, in the real world, there's a lot of times that's what we're testing. I'm trying to determine if these events are independent or dependent. So like researchers or any of that, they'll look at these things and try and decide, does this affect this or are they independent? Okay, so a lot of times we have to test for independence using the data that we're given. So we have two independence tests that we can use. Things to remember is the formula for independent events is the probability of A and B equals the probability of A times the probability of B. Okay? This is true, right? We can use this formula when events are independent. So we can also use it to check for independence. It's kind of like what we do with Pythagorean theorem, right? I can use Pythagorean theorem to find a missing side, or when we had all three sides, I can check to see if it's actually a right angle, okay? So if I have all three of these things and I throw it at all of them into my formula, if it's true, right, then yes, they're independent. If it's not true, then no, it's not independent. Okay? Similar for conditional probability. Conditional probability is a little stranger though, right? So we have probability of B given A, which equals the probability of A and B over the probability of A, right? Well, as we looked at yesterday, right, if I can find that and probability, right, we can use this. If these are independent, it's going to be a B. Right, the probability of A and B is the same as the probability of A times the probability of B divided by the probability of A. And then if you look, this should be the same as the probability of B. So if your given probability is the same as your regular probability, then they're independent, which that makes sense, right? If I want to find the probability of rolling a 4 on a die, given I rolled a 2 already, well, rolling that 2 shouldn't affect what I get on my next roll. Those probabilities are going to be the same. Where the ones we looked at yesterday, if I do something without replacement, right, the probability has changed. The regular probability would have been out of the regular total, but our new probability was already, the total was already one less. Those probabilities were not equal. Okay, so this is our test if we're given something with conditional probability. Okay, the probability of B given A should equal the probability of B. All right, looking at example 1, determine if events A and B are independent. Okay, so here I have the probability of A, the probability of B, and the probability of A and B. So I'm going to do the probability of A and B should equal the probability of A times the probability of B. So that's 2 over 25 should equal 2 over 5 times 1 over 5. Well, 2 over 25, well, 2/5 times 1/5 is 2 over 25. These are independent. Same thing for this one, right? Probability of A and B equals the probability of A times the probability of B. our A and B is 1 out of 25. Is 2/5 times 1/4. I'm just going to do this in my head, right? 2/5 times 1/4 is 2/20, which is 1/10. So these are dependent because they are not equal. All right, looking at C. Now we're given the probability of A is 9 over 20. The probability of B is 1/2. And the probability of B given A is 27 out of 50. So in this one, I'm going to use my conditional probability because it gives me a conditional probability. So I have to switch to my other formula. S equal the probability of B. So that's 27 out of 50 has to equal 1/2. That's not true. Those are going to be dependent. Same thing for D, probability of A, probability of B, and then the probability of B given A. So I'm going to use that probability of B given A independence test. And I have 3/10 which equals 3/10. So therefore, those are independents. Okay, so that's if I'm just given the probabilities. Now we have to look at our word problems because that's most likely what these questions will be, right? It gives you a scenario and you have to decide whether they are independent or dependent. So the probability that a student passes a quiz is 80%. The probability that the student uses an online textbook is 60%. The probability that a student pass the quiz and use an online textbook is 32%. Is passing the quiz independent of using the online book? So the two biggest issues with these types of questions is that students get confused with is what it's actually asking for. So we really want to pay attention to what the question is asking. Is it independent, right? So if it's asking something about independence, we know we're going to use one of our two independent tests, right? Either the and probability or the conditional probability independence tests. The second thing then is deciding which one to use, right? And that's reading through the problem and seeing which of those two probabilities you have. If you have the and probability, you should use that one. If you have the conditional, the given probability, you should use that one. So the probability that a student passed the quiz and use an online textbook is 32%. So we're going to use our and probability formula, right? The probability of A and B has to equal the probability of A, probability of B. So the probability that they passed, pass and put a B, probability of passed and online should equal the probability of passed times the probability of online. Again, write out the words. In these word problems, the easiest thing you can do is write out the words. It's the same thing we did with our and our or in the first half of this unit, right? Putting it in words and writing out that formula is a lot easier. So the probability of pass and online. Pass and online is 32%. So I'm going to put it in as 0.32, right? We want to make sure we get it to a decimal. The probability of passed, student passes a quiz, is 80%. Probably that they had an online textbook is 60%. So then I get 0.32 And 0.8 times 0.6 is 0.48. Again, feel free to use a calculator. No, these are not equal. So I'm going to say no, they are dependent. Okay. So passing a quiz is dependent on whether they use the online book or not. Now, these tests tell me nothing about this situation other than one affects the other. Okay? I don't know if using the online textbook is more helpful, less helpful. This tells me nothing about that. All I know is that using the textbook, online textbook, is somehow going to change my probability of passing, whether for the better or for the worse. Okay? All right, looking at our next example. In a sample of 100 students at community college, 60 were full-time students and 40 were part-time students. 20 of the full-time students intend to transfer. 10 of the part-time students intend to transfer. Is intending to transfer independent of being a full-time student? So again, it's asking my independence. And then I want to figure out, is this an and probability or a given probability? So this one, we have to kind of read between the lines a little bit. So 100 students went to a community college. That's one thing happening. That's one of our simple probabilities. 60 were full-time and 40 were part-time. Okay? This tells us one thing and then a different thing. That's not our and probability. But 24 of the full-time students intend to transfer. So 24 of them are full-time and intend to transfer. That is an and probability. 10 of the part-time students intend to transfer. Again, 10 of the students are part-time and intend to transfer. That's also giving us an and probability. So I am going to use my and probability test here. So here, right, is intending to transfer independent of being a full-time student. So I'm going to do full-time and they're transferring, right? And I just say that because they're full-time and transfer is the order they went here. For and, the order doesn't really matter. In your conditional, the order does matter. So the probability of A would be the probability of full-time times the probability of our transferring. So full-time and transfer, well, there's 24 of them, and it's out of 100. So that's 24 out of 100. Just full-time, 60 were full-time. Transfer, 40. Oh, how many have transferred? 24 of these guys transferred, 10 of these, so that's 34 out of 100 we're going to be transferring. Okay. So they can do either of these. Kind of like our totals when you were doing all the or. Sometimes you have to add things up. So 24 out of 100 reduces to 6 out of 25. And then 60 out of 100 times 34 out of 100. Sorry about all the bells. Is 51 out of 250. Okay, so these are not equal. So no, they are dependent. All right, looking at Example 6. A survey of students in homeroom class found that the probability of being in band, given that you are a girl, is 62%. The probability of being in band is 46%. Is being in band independent of being a girl? So again, it's asking us, is it independent, right? Now this one doesn't have an and, but it does have that given probability. So we're going to use our conditional independence test, not our and independence test. So the probability of B given A has to equal the probability of B. Again, these ones, it's very important that we use the words a lot of times. So the probability of B given A. So band given girl. So this is B and this is A, so it has to equal the probability of band. So our given probability, band given girl, is 62%. And the probability of being in band is 46%. Oh, those are not equal. All of these are dependent today. No, they are dependent. Okay, so these ones are a little easier. It's just if one thing's equal to the other. All right. Same thing with number 7. A recent poll asked whether customers like a restaurant's new lunch menu. The probability of someone liking the new lunch menu, given they are male, is 0.44. The probability of liking the new lunch menu is 0.44. Is liking the new lunch menu independent of being male? Show work to support your answer. So again, is it independent? So that's the type of question it's asking. And then we have our word given here. So we're going to use our conditional. So that's the probability of liking given male. So this is B and this is A. So that has to equal the probability of liking. So the probability of liking given male is 0.44. And the probability of liking it is 0.44. So yes, they are independent. There we go. Okay. Otherwise, that is it, and I'll see you guys tomorrow.